This is Team Gobe from first year class 5. I'm going to teach you about advanced material, which is known as new materials. Today, we're going to learn about new materials using nanotechnology, and new materials using ecological imitation technology. New material is materials that realize high function and structural characteristics by supplementing defects in existing materials or creating excellent properties. I can see that you're already bored, so I brought some current new materials used in the past movies. In Mission Impossible 2, there is a scene from a movie that recognizes iris among biometric technologies. At that time, biometric technology did not exist, but biometric technology is currently being used in smartphones and other security products. And in Mission Impossible 3, there is a scene in the movie that makes a mask modeled after another person's face by using a 3D printer. 3D printing technology did not exist at the time when this movie was made, but now 3D printing technology makes a variety of things, including buildings and food. Now, we move to the next part about new materials using nanotechnology. This is a new material that changes the bonding structure or arrangement of atoms in nano units. There are many new materials using nanotechnology, but today we're just going to learn about two things: graphene and carbon nanotube. Graphene is a material with a planar structure in which carbon atoms are connected in a hexagonal honeycomb shape. Graphene transfers heat and electricity very well, and it's transparent. Also importantly, graphene is hard but bends well. Graphene is used in conductive ink in daily life. The wearable computer and the transparent display, which were shown in the movie Iron Man, are the use of graphene too. So, how could we make graphene like this? And can we make graphene in our daily lives? Let's watch a video related to this.
Picture this. You were thrown into a dingy room and told you can't leave until you have created the thinnest material known to man. Not only that, it must also be the strongest, the best film conductor, and as good at conducting electricity as copper. I know, it sounds hopeless, but luckily, you know something about nanotechnology. You know really tiny devices and materials that are less than 100 nanometers in size. Of course, I don't have to tell you, a nanometer is a billionth of a meter. That's roughly the size of 10 atoms. But how do you create something that tiny? It's time to embrace your inner MacGyver. You're going to need a pencil, some scotch tape, and a healthy dose of velvet grease. A pencil contains not lead, but graphite, which consists of sheets of carbon in hexagonal lattice. When you write, layers of graphite slide off the tip of the pencil and stick to the paper. Usually many layers are stacked on top of each other, but once in a while, you get a single layer of carbon atoms, and this is called graphene. In 2004, Andrei Gain and Konstantin Novoselov created graphene using nothing but graphite and scotch tape. They placed a graphite flake onto the tape, folded it in two, and then cleaved the flake in half. They repeated this procedure a number of times and then studied the resulting fragments. To their astonishment, they found some of the pieces were only a single atom thick. This was particularly unexpected because it was thought a single layer of graphite would not be chemically stable, especially at room temperature. Graphene conducts electrons faster than any other substance at room temperature. This is because of the extraordinarily high quality of the graphene lattice. Scientists are yet to find a single atom out of place in graphene. Since the electrons aren't scattered by defects in the lattice, they go so fast that Einstein's relativity must be used to understand their motion. And this perfect lattice is created by the very strong yet flexible bonds between carbon atoms, making the substance bendable, but harder than diamond. Graphene is incredibly strong. If you could balance an elephant on a pencil and support the pencil on graphene, the graphene wouldn't break. Of course, the pencil would. For their discovery, Gain and Novoselov were awarded the Nobel Prize for Physics in 2010. And this is only the beginning for graphene. Scientists are hard at work exploiting its unique properties to create Thin, transparent, flexible touchscreens, smaller, faster, more energy-efficient computers, tough composite materials, and more efficient solar cells. And now consider, this is only one aspect of nanotechnology. So in order to think big, you need first to consider the very small.
The second new material using nanotechnology is carbon nanotube. Carbon nanotube is a material in which graphene is rolled in spiral shape. It transfers heat and electricity very well. There's an amazing object made by carbon nanotube. This is Vanta Black. Vanta Black is a new color developed using nanotechnology. It absorbs most of the light that has entered through the process of building fine carbon nanotubes and reflecting each other countless times between the tube and the tube, which, when using Vanta Black, it absorbs 99.6965% of the light. Like combat clothes in Spider-Man, space elevator in ice space supers, comfortable spacesuits in The Martian, is the use of carbon nanotube in the movies. The last thing we're going to learn about is ecological imitation technology. This is a technology that mimics the behavior, structure, and characteristics of living things. For example, dogs that can climb walls in the movie Mission Impossible imitates from a gecko lizard's feet. It can use fine cilia on the soles of its feet to stick well to trees or walls. Currently, gecko lizard's fine cilia on the sole is used to make medical patches and a robot that climbs vertical walls and more. And the Spider-Man's web in the movie imitates from the spider web. The spider web is very thin, but it is 5 to 10 times stronger than steel and has excellent elasticity. In daily life, artificial tendons, bulletproof jackets, and parachutes are the new material used products using spiderweb ecological imitation technology. Today's lesson will end here. See you next time and review.